Hi everyone, today I want to start tackling what is the main topic of this Quasi-human series, the spinal cord injury. So this is Quasi-human, a scientifically accurate fiction. It's a book that I authored that revolves around contemporary science and how it might affect our future. The story is about two characters and both of them are suffering from a spinal cord injury. Now one of them is an engineer who's developing a device that will eventually reverse the condition, and the other one is the person that's going to wear it first. In these videos I'm going to unveil a bit of the science behind this story, but you don't need to know the story to understand what I'm about to say, because it's real science. Although if you're curious, there is a link up there that will explain you everything. So the spinal cord injury is probably the most common excuse to justify a person on a wheelchair. However, this is a bit reductive. Actually, it's a lot reductive. What the spinal cord is, it's a cord that runs from the top of our neck all the way down our spine, and it branches out and connects to every organ of our body. Now it has two functions. One is telling our organs what to do, so transmitting orders from the brain to the different organs, and the other one is signaling back to the brain whatever our organs are feeling, such as touch, temperature, or pain. So when the spinal cord breaks, all communications between the brain and every organ that connects below the point of rupture is interrupted. Now, if the damage is very low, the only thing that's going to be cut off is our legs. So we get paraplegia, the paralysis of the legs, which is the most common of the symptoms. But as the damage goes higher and higher, we lose control over our bladder, our bowel movements, we might lose control over our lungs and stop breathing autonomously, we might get paralysis of our upper limbs, we might even lose the ability to speak. So let's stop for a moment and look at this problem from a different perspective, a more engineering perspective. What we have here is the biological equivalent of an electrical cable that it's broken, so the signal doesn't pass across. If we were robots, we would just open our body and substitute the cable, or we might decide to repair the cable or bypass the point that it's broken. Either way it works, right? The only thing is that we are not robots, we are living things, and that complicates things a bit. The thing is that only maybe in the last couple of years, scientists have been showing how they could finally repair a spinal cord injury and reverse some of the effects. With which method, you ask? Well, all of the above. And have they all been successful? Yeah, kind of, with their own limitations. Now, this is one of the rather unique cases in which scientists have been trying to solve a puzzle using many hypothetical solutions, and they found out almost at the same time that all of them are actually feasible. So there is a sort of unspoken competition among scientists to find out which treatment is best, more feasible, and offers the best outcome. And obviously to find out who is going to be the first one achieving that kind of treatment. So it's worth knowing what these techniques are, and they involved a lot of good stuff. They involved exoskeletons, VR sets, regenerative medicine, and even brain-computer interface. So the first thing I'm going to mention is exoskeletons, which are basically chunky robots that we can wear, and they allow us standing straight, moving around, lifting objects, and so on. And apart from being chunky, expensive, and not really sexy, they require a whole system to be maneuvered, okay? Which is a whole different problem. However, the deal with exoskeletons is that they can be used along with other techniques to make them more effective. So for example, we want to use brain plasticity to sort of self-heal the spine. Okay, brain plasticity is the ability of the brain to rewire itself, and it does phenomenal things. However, that requires a lot of exercise and some rig to help out the patient to recover. We might want to use a VR set and an exoskeleton as a rig. So once the patient is into the exoskeleton with this VR rig, he can walk by itself and experience how walking feels like for real. And this actually aids the brain to remember how to do it, okay? We might also use another device that sends electrical impulses to the spine, and that also aids the process. Now, these techniques have already been proved successful people have been recovering, small movements of their legs and feelings and so on. However, these movements are not strong enough for a person to walk by itself, but they can be used to control an exoskeleton, for example. So, another approach might be using regenerative medicine to repair the spinal cord itself. What we can do is that we can deliver some stem cells straight into the lesion using maybe an hydrogel implant, okay, and wait for them to restore the spinal cord. On the other hand, we might decide to pick those parts of the spinal cord that are broken and reroute them through a different and undamaged path and wait for the body to restore itself. Now, all of those are probably the most promising techniques, mostly because after the surgery they don't require any additional implant or robot. However, they do need very delicate and very invasive surgeries to be applied. The last running up solution is the brain-computer interface. So let's say that we make a device that reads brain signals and translates them into digital information, so a 0110 kind of information. Then this device sends this information to another device that is onto the spinal cord beyond the point of rupture. And the second device buzzes the information back into the spinal cord and restores the motor function. Now, if the second device is also capable of reading sensorial function from the organs and sending back to the first one to be retranslated and resubmitted into the brain, we have effectively created a substitute for the spinal cord and solved our problem. So between all these different techniques, there is the solution for eradicating paralysis altogether. The challenges are mostly regarding how many implants and how difficult and complicated these implants are, or how dangerous is the surgery. For example, if we want to use a brain-computer interface, what we don't want to do is opening up the skull and putting the electrodes on, because that comes with a lot of dangers. It might be even more dangerous than paralysis itself. So, we can use different techniques. We can probe through the blood vessels, or stick some electrodes straight into the brain without opening the skull. These solutions are open, and what's exciting is that progress is coming, and it's coming all at once and sooner rather than later. In the meanwhile, make sure to remember that not everyone with a spinal cord injury is facing the same challenges. For some people, being on a wheelchair is their major issue. But for others, the wheelchair is only a small part of a much, much bigger challenge. And on a completely different note, some of the techniques that we explained today, they might open doors to completely new branches of medicines and treatments for other diseases, which involve the interaction between the brain and computers, AIs, and so on. However, that is a discussion for a completely different video. If you like this video, please consider sharing it, subscribing to my channel, or following me on Facebook and Twitter. This video is part of a Quasi-human series about this book, which is a rather engaging story that revolves about contemporary science, and it's about two paraplegic characters and a team of scientists in their journey to develop a treatment for this condition, with the interference of obviously governments and corporations and so on. If you want to read more about it, or if you want to purchase the book, you can follow the link up there or in the description of the video. As for now, thank you for listening and take care.